Working in Manaras JJ College of Engineering, Natalam. Today we can discuss about aircraft structure. Aircraft structures or airframes are highly engineering lightweight framework designed to skillfully withstand aerodynamic force, gravity, and operational stresses. They consider five mainly components: the fuel slate, that means main body, wings for lift, empennage, tail, flipping control, and landing gear. The most modern aircrafts use as semi-monotrophic designs. Distribution load through a stress scale, reinforcement with internal frames, spring spars, and ribs. Outlines of representation. We can discuss about aircraft components, metals used in airframe construction, assembly for metals used in airframe construction, fuel lead structures, stress tribes, part tribes, radar tribes, monocrope, semi-monocrope, base structures, member teams, wing structures, embedded structures, power plant, wing port mount, fuel lead mount, land gear structure. Aircraft components. Aircraft components means fuel ledge. Fuel ledge means the central body holding these two passengers and carriage, which acts as the main anchor for acting the wings, tails, and engines. Wings. Airfoil the generate lift internally. They rely on heavy spars to support bending loads and rib to maintain their aerodynamic space. Empennage. The tail assembly is concept of the vertical and horizontal stabilizers, which provides stability, and the movable rubber and elevator, which control pitch and prop. Flighting control hinges such as ailerons, flaps, and trim tabs that allow the pilot to maneuver and adjust flight attitude. Land gear or undercarriage. The undercarriage structures that support the aircraft on the ground upset the stock of taxing, takeoff, and landing. Therefore, aircraft such as we showing the figures to the wings, horizontal, I mark the vertical stability, rubber, elevator, embedded. Fuel ledge. Fuel ledge means main body of the aeroplane, pilot and carrier comparing general construction in two or more sections, carriers, accessories, and other equipments, including numbers, accessories, door, inspiration, plates, landing, wheel wear, and other opening. Wings. Airfoil attaching to each side of the fuselage, mainly lifting surface. Various designs, structures, and shapes may be attached at the top, middle, or lower position of the fuselage. High wings, mid wings, and low wings. The number of wings can also vary. Monoplanes or biplanes. Empennage. Nodes of tail section consisted of vertical stabling, rubber, horizontal stabling, elevation. We can be showing in the figures. Power plant. Power plant means a unit of machine that converts chemical energy contained in a fuel to thrust force. Thrust force is essentially for moving the aeroplane forward and providing lift force with the position engine. The propeller is used to convert touched engine said to be thrust with the jet engine. The jet engine output is thrust of force. Landing gear. Landing gear location under met of the fuel with stock start. Fist providing means the land taxing, tie cycle, conveying types, floating gear for steep plane equipped for ice, surface landing, etc. Metals used in airframe construction. Airframe measures properties: high strength to weight ratio, lightweight, corrosion resistance should be not favorable, high quality. Example for metals used in airframe construction: wood, steel and its alloys, aluminum and its alloy, titanium, magnesium, plastic and composite metals. There are examples for the airframe. Types of structure: truss, monochromic, semi-monochromic. Truss used a rigid framework of weld steel, tube and wood, commonly used in lightweight and horizontal aircrafts. Monochromic means release almost ended on the external air skin and handle all loads, while individual strong is of little inner volume and is heavy. Semi-monochromic: the industrial standard is combined a thin metal or composite ester skin with an internal network of forms, bulkheads and longers to distribute tensile, tension and compression load effects. Fuel blades structures: basic structures trice, flat truss, parent trice, monochromic, semi-monochromic. Structure types: most earlier aircrafts used two techniques with wood and wire truss, and these types of structures is still in used in many lightweight aircrafts using welding steel tube trusses. These trusses types flukage frame is assembled with member forming a rigid frame. Example: beam, bar, tube, etc. Primary member of the truss are four longinus. There are two types of truss: Pratt's truss, Warden truss. Pratt's earlier days, wooden or metal such as great weight, difficult to streamline, was with tubular vertical members. Warden truss means only diagonal members, force transfer to every other such as cable to carry tension, press, compression, reduce among the webs, work, more space, strength, rigidity, better streamline. Force engages: aircraft such as must endure high primarily mechanical stress during flight and ground operation. Tensions: pulling force that stress the metals, compression, sequence force that crush or metals the metals, shear, opposite force sliding across the metals, blending, a combining of tension on one side and compression on the other, torsion, twisting force. Monochromic: in this method, the steel surface of the flukage is also the primary structure. A typically earlier form of this base was built up using molten plywood. A later form of the structures used fiberglass cloths embedded with polosisic or Epson resistance instead of plywood as the skin. Semi-monochromic: this is the preferred method of construction and all the aluminum flukage. First of the series of frames in the shapes of the fluids across section and held in position on a rigidity fixture or JIT. These frames are then joining with lightweight longitudinal elements called stringers. These are in turn conveyed with a skin of sheet aluminum, attached by riveting or by the bonding with special adhesives. Most modern large aircrafts are built using the technique but use several large section constructed in the fashion, which are then joining with the fashion to form the complete fuselage. We can shown in the figure semi-monochromic structure for an airplane. Basic structure: member tanks, vertical members, forms, frame rings, bulkhead, longitudinal beams Members, long and stringers. Wing structure. Many high-wing aeroplanes have external barriers or wing structures which transmitted the flight and land loads through the structure to the main fluid structures. Since the wing structures are usually attached approximately halfway out on the wings, this type of wing structure is called the semi-cantilever. A few high wings and most long wings aeroplanes have a full cantilever wings designed to carry the load without external struts. The principal structural parts of the wings are spar strips and stringage. These are reinforcement by truss, I-beams, coupling or other device including the skin. The wind ribs determine the shapes and thickness of the wings. Wind structures. In most modern aeroplanes, the fuel taken either or an internal parts of the wing structures are considered a visible container mounted inside of the wings attached to the rear or trailer edge of the wings are two types of control such as refers to as ailerons and flaps. Ailerons extend from about the midpoint of the each wing otherwise towards the tip and move in opposite direction to create aerodynamic force that cause the aeroplane to roll. Flaps extends outwards from the fluid to near the midpoint of each wing. The flaps are normally flat with the wing subjects during thrusting flight. When extended, the flaps moving simultaneously downwards to increasing the wings lifting force of the wings for take-off and landscape. Wing example for the wing structure of an aeroplane line. Empennage structures. The correct name of the tail section of an aeroplane is called empennage. The empennage, including the ended tail group, consists of fixed structures such as the vertical stability on a horizontal stability, the movable surface, including the rubber, the eligible on one or more tape and second types of empennage. Design does not require an elevator. Instead, its incorporation on a one-piece horizontal stability that pivot from a central hinge point. This type of design is called stability and is moving used to control stick, just as you would to elevate. Empennage of the aeroplane, vertical stabilizers, horizontal rubber timber elevator. Aeroplane structures we can be showing in the figure. Landing gear structure. The landing gear is the principal support of the aeroplane when parked, taxiing, taking off or when landing. The most common types of land gear consist of wheel, but aeroplane can also be enclosed with floating of for water operations or skins for landing and snow. The landing gear consisted of three wheels, two main wheels and third wheels positioned either on the front of or rear of the aeroplane. Land gear employed and recommended wheel is called the conventional land gear. Land gear such as aeroplanes with conventional land gear or something refers to as tail wheel aeroplane. When the third wheel is located as the nose, it is called nose wheel, and the design is referred to as a tricycle gear. A stable nose wheel or tail wheel permitted the aeroplane to be controlled throughout all the operation while on the ground. Power plant. The power plant usually include both the engine and the propeller. The primary function of the engine is to provide the power to turn the propeller. It is also generate electrical power provides a vacuum sources for some flight instruments and is most single-engine aeroplane provide a source of heat for the pilot and passengers. The engine is covered by the cowling or in the case of some aeroplanes surrounded by the nozzle. The purpose of the cowling and or nozzle is to be streamline the flow of air around the engine and to help cool the engine by ducting air around the cylinder. The propeller mounted on the front of the engine translates the rotation force of the engine into a forward acting force called thrust that helps moving the aeroplane through the air. We showing in the figures wind port mounted commonly used a commercial aeroplane since fuel is carried on with less nose. CLmax is not a good is as fuselage mounted working moment effect ground clearance limiting higher grade thrust. Fluage mounted cleaning means high CLmaxes shortage of no ground clearance limit less wearing effect weight friendly air CG and load distribution cabin nose and vibration. Thank you. Have a nice day.